Okay. We're live here. Let me send out a couple quick links real fast. Let people know that this is live. Post that. Okay. All right, let's hopefully everything runs smoothly this time. Change some of my settings. I was having a weird issue the last couple of streams where like the bitrate would just drop to like 100 for just randomly. And I'm not 100% sure why, but yeah. In any case, see if anybody pops in. How's everybody doing today? And hopefully the audio is okay. Let me know if it's not. Changed my setup a bit. I moved stuff around. I got fancy lights behind me now, which is kind of cool. I might post before and after photos, but I basically like swap my desk space around so my computer's in a different place and put in a whole bunch of shelving because things are getting a bit crowded. But yeah, in any case. So in this stream, I'm going to design the third version of the tiny ESP32. I posted a video last week of the second version. I did like a short 5-minute recap basically. And got a whole bunch of really good ideas from people. Some, it's one of those things where like, you know, I got rid of the Wi-Fi to try and make it smaller. Things like that. And obviously a lot of people really love their Wi-Fi. So I'm going to try and add that back in. But some of the ideas that people had, a lot of the kind of standard ones were, you know, hopefully that doesn't. A lot of the standard ideas people have is like, get rid of the USB. You don't need that. Get rid of the buttons. You can like make pads and then short it out with like a screwdriver if you need to put it into download mode or something. And that's definitely a possibility. But it's not super user friendly to do that. So while it is an idea, somebody else commented, and I wish I could remember who it was off. I don't have the comment up, but they suggested using a specific type of connector. And I was like, okay, I've never heard of that connector before. Apparently it's really small. So I decided, okay, let me look this up. And it is legitimately a very tiny connector. And I'm gonna go to my microscope real quick. Hopefully you guys can still hear me. So they come in different sizes. This one's 10 pin. This one is 20 pin. And basically what it is one of these is the plug and one of these is like the mate. So this would snap inside of this. Now, how small is this? And of course, I don't know what I did with the little, oh, here it is. So this is, I'm going to put the actual PCB up next to it so you guys can see. So this is the PCB that I, made for my second revision, and these are the connectors. I don't remember what they're called off the top of my head, but they're extremely small. And, which this really got me thinking. I was like, huh. Hi, Starfish. My wife. In any case, this really got me thinking. I was like, I don't want to get rid of the USB and buttons and stuff because that can, I don't want to make it more difficult to use. But if I basically could use these connectors and then have basically little shields, that's another PCB that's kind of like this, that could be the USB and connector that you could just snap on so you can program your board. And then when you're done with it, you can pop it off. Same thing is you could pop in a shield that has a bunch of I/O broken out. So if you wanted more I/O, you could do that. You could do another breakout shield that has like a battery connector on it. So the actual ESP32 itself can be really, really tiny. Let me, I'm gonna back this camera up a little bit. Hopefully it's not as close. If I can get it focused here. There we go. So that's kind of the thought process I'm having. So that also allows me to offload some of these components to, you know, some of these breakout boards, and that will leave me room to hopefully install an antenna. There's a bunch of really small antennas. I said have fun. There's a bunch of really small antennas out there. I have some, but I don't know if I have the smallest you can get. And I was actually, if I can figure out what I do with my little Adafruit. Here we go. Does this have an antenna on it? Nope, that one. This one does. This is one of the Adafruit boards, and that's their antenna. So that's doable. Like, I think we could get that on one of these boards. So we're gonna lay this out, and the idea being is we're gonna stick one of these connectors on the back side of it. And I was gonna say, I thought I lost. They are really small. One of these connectors on the back side of it. Then, yeah, we'll see how big and small we can break this thing out. So, I'm gonna come back here. Let me, so I got one that has 10 pins and one that has 20. I think we can put the 20 on it. The only downside to this particular connector that I can see is that it looks like it's reversible, so you can plug it in either way, which make it, you have to make sure the pins are right, because if you accidentally plug it in backwards, you don't want to fry something if the 3-volt pin is going, or 5-volt pin's going somewhere it shouldn't, if you have it in backwards. So we're going to take that into account. It's one of those things where, like, I think I could probably put the, you know, ground and the, you know, like, the voltages have like double pairs on each side, so that it doesn't matter if you flip it back or forth. And then the GPIO pins, they can be swapped around from one side to the other, but the naming convention might be a little weird. I hope that makes sense, but regardless, let's get into it. First thing I'm gonna do is I'm gonna go to Mouser real quick and look up these. Give me a second. If I can, let's do this. Mouser is like super slow. There we go. Okay. And let me look up this part number real quick. This one is the 20 pin. I just want to, I don't know if they have footprints for them. I didn't think to look. 20 DP. That's gonna be that one. And I just realized that give me a second here. Oops, not that one. Try and fix the chat a bit. Okay. All right, so this here's our one of the pins. Let's see what we have here. So they have everything. That's good. I gotta log in. Hold on, let me do this off screen real quick. Put that one there. And all right. Make sure I'm not showing anything I'm not supposed to. That's always a worry. Okay. I can't remember. Let's see if that's one way to do it. Okay, yeah, so this one downloads it for everything. So I need this one, and I need the other end for, and I think for this one, What do I do with it? I'm missing one of the, those are those two. What did I do with the other one? Great, I've lost one already. That's, oh, I think it's down here. Got it, okay. And I need this one as well. So I'll set this off to the side here. And let's look this one up real fast. So you need both ends of it. You need like the plug, and then you need the actual, you know, whatever you want to call it, the other end. Yes. This one is that one. Oh, well, that's not. Well, that one didn't have a. That's the right one, right? Let's see if DigiKey has it. Second here. Oops. Okay. I think Snap EDA might have it. So let's see. I gotta log into this. Gotta log into everything. Okay, so this should be the other end. I don't know if it has the 3D model here or not. KiCad. Okay. 3D model? Not here, they don't. Let's see if Ultra Librarian has it by chance. That doesn't look quite right as far as the model goes. One has got, well, I guess it's kind of close. Just the actual part that comes up doesn't look that hot. Okay, so we'll download this. Oh, of course, I gotta log into this one too. Well, I guess all I need is a 3D model, which isn't super important, but let me download. Okay. So we've got those two. Need to install them real quick. So give me 1 second here. It's desktop. Oops. New window. Okay. And KiCad. Nope, not that one. Yeah, it should be parts. And drag it over here so you can see what I'm doing here now. What do I want to call those? Because the actual product name is kind of long. Let's just call it 20-pin connector. And let's go new folder. 20-pin plug. So we got connector and plug. And of course, I don't remember which is which. 20, the DP is the plug, which is this one here. So let's go KiCad. Plug. We're gonna take those in there. And then we're gonna go to connector. I need to go to the other one that I downloaded, which is DS. Oh, that's the, okay. So that's our DS there. And the 3D model, we'll just throw those in. Okay. I got that. The rate still looks okay. So I'm gonna need to add these real fast. Get the symbol. user, import symbol, parts, 20-pin connector. Okay, save that, then import the plug. Should be that one, I think. Okay, save that. Okay, those are those two, we got that. And then the other thing we need to figure out is which antenna we want to go with. I'm going to look up the one that Adafruit used. See if that one makes sense. Import footprint. Parts. 20-pin connector. Okay. Get rid of that because I don't like having that there. And save that there. That's the connector. And then import footprint. Let's go plug. Get rid of that. And hit save. User save. Okay. So we got those. Now let's go to Adafruit real quick. ESP32 S3 QT Pine. I don't know if I spelled that right. Yes. Okay. And it's fine. Nope, not that data sheet. Not this one. And let's go to downloads. And I don't know if this is going to tell us. It does not tell us what the antenna is, which is not ideal. Let's hoping it would. I think they. And let's go to the GitHub. Guess we'll just download this. The schematic should have the. Hopefully has the actual part number. That'd be very helpful, but we can always look it up ourselves. I mean, we have to try and find something, but let me open this. Auto match. Okay. All right, this is theirs. That's the USB. This right here is what they're using. And it just says. Okay, so we need to find some antennas then. See what we can find. I have I have one little one in here somewhere. And I think my office space is an absolute disaster, but I rearranged my desk, and so there's just a bunch of stuff on the floor right now. Pull this over here. Not very prepared today, unfortunately. Come on, move. All right. And so that's the big one. Let me see if I can find the smaller one I have somewhere. Every time, it's just me looking through random files here, or bags, trying to find the right one. I know I threw it in here the other day. Again, one of those things where I'm like, hey, I'm going to need that, probably, you know, for the stream or whatever. And then I misplace it. And of course, it's the one I want the most. I throw it down here. Let's see. Not there. Sorry, guys. Bear with me. legitimately don't know what to do with that. And it's like the one it's the one thing I need, and I don't know what I do with it. Those are a bunch of... So annoying. So annoying. I just want to compare it, dang it. Did I stick it in here? Stuck it in here or not? No, I did not. Hold on, I'm looking. Sorry. Where did it go? Those are not it. Now, if I can't find it soon, I'll just start looking up online. This is riveting. Like, watch me just trying to find components. I need to try and organize this stuff better at some point, but when you get all these little baggies with all these parts in them, they all blend together at a certain point. Alright, well. I know I have it somewhere. It's so annoying. I stick it down here. Alright, well. Alright, I'm not going to keep looking. People just like start leaving left and right. Like, well, alright, well, that's cool watching you search through your components. I really wish I knew what the heck I did with that. Okay, so I think I bought them from LCSC. Let me look in my history here. Sign in. History. Actually, finding it in here is going to be an absolute nightmare. Because I have tons and tons of orders. Okay, I don't think it's that one. It's one of those things where, like, I really should have just found it earlier. Stuck it out so I'd have it. Let's see. Nope, not there. Anyways, how's everybody else doing? This is... There it is, found it. Okay, this is the one that I have on hand, or one of them. I need to find out how big it is. That's what I'm most curious about. So it is 1.6 millimeters by 3 millimeters, basically. And the Adafruit one, find out real quick. The Adafruit one is, yep, don't care about that. Let's see if it's in the same ballpark. So the one I have is even smaller than that. Does that seem right? That is, yeah, 3 millimeters by 1.6. So the one I have on hand somewhere is actually smaller than the one they have, which is actually encouraging. Gosh dang it, what did I do with that? It's in here somewhere, I know it is. I want to be able to take one out and like set it on my old, like the version 2 board and just see how big it is in comparison. That one's not it. Nope. Nope. So I know it's an LCSC bag. No, that's a crystal. That'll help me narrow it down a little bit. What's this one? Nope, that's not it. This is brutal. Literally. Nope, those aren't it. It's one of those things where, like, so I cleaned my desk, right? Cleaned it all up. You know, it was sitting on my desk at some point amongst the clutter. And I remember sticking it, like, oh, I'll stick it in here. That way I know where it's at. And then, you know, I immediately forget what I did with it. Golly, that annoys the crap out of me. All these drawers. LCSC bag. That's not it. Those aren't it. Down here, maybe? Good clock. No. I don't know what that is. What is that? No. So frustrating. What in the heck should I do with that? Okay, well, we know this. We know it's smaller at least. It's here somewhere. So we know it's 1.6 by 1.2. Do they tell us where the pads are at? Okay, so we got some information here as well, which is good. So usually it tells you where the pads are at on the bottom. Okay. Yeah, I guess we'll just make it to that spec more or less. So we don't need that. Discard that. We're gonna, do I have these open already? Got this one, we've got the antenna. And actually I think the antenna we need is, let's see. I don't know if that's it or not. Try to, let me look up one of my older ones. Hold on a second. Let's see here. That would be, stuff's kind of scattered to the wind too a little bit. Google Drive. And let's go. Nope, that's not it. Nope, that's not it. Hey, okay, I'm not gonna be able to pronounce your name, buddy. I don't give a fuck. J83K92. Guess I shouldn't have said the F word out loud. Sorry. Yeah, I use this particular one. I just used is 1 millimeters is the thickness of the PCB, so it's thinner than, like, you know, a standard 1.8. Let me find my PCB files. Yeah, here we go. Let's go with this one. At least I thought. Is there nothing in there? There we go. That's what I want. Oops. Get rid of that. Put this in. The one I'm replacing it was a UFL connector. But UFL connectors are actually fairly large. Okay, so we got that. We need to create a footprint for the antenna that I have somewhere out here. Let's go new footprint, tiny antenna. Hope I spelled that right. And let's go put some pads down. Figure out how big this needs to be here in a second. Do silk screen, and it is 3.1 by 1.6. So 3.1 by 1 point. Get it. Right, okay, right there. So that's how big our antenna is. Maybe I'll just, do this. Something like that. Shrink this up. It doesn't say on the data sheet how big these pads should actually be, so I'm kind of... I probably could. 1.4 might be hard to get done, but I think like the standard PCB houses can do like 1.6. Yeah, right. Sorry. I need to have a mute button, or a beep button rather. Okay, so let's go with that, I guess. And actually, let's make this just a touch bigger. Something like that. Save, tiny antenna to user, save. Okay. All right, we're getting to the fun bit here. No, I know. 1.1 or 0.6. I think I can get done somewhere. Like I think the PCB houses I use will do that. 1.4, I'm not sure, or 0.4, I'm not sure I've seen too much of. Hopefully, that's right. Okay. Well, we'll see. We'll see here in a second. So we need to get rid of. Let's add in our special connector that we Yeah, it's probably in user, and of course I don't remember which one it is off the top of my head. We want to put the DS one on the bottom, I think. So it'll be this one. So we want this. We don't need the. We don't need those. We got the crystal. We have the RGB LED. We have the power regulator, or voltage regulator rather. We have that, and we can actually get rid of this. We can put this on the USB breakout. For those of you who may have joined after because I initially explained kind of the road we're going down. I got a good after midnight. What are we building? Hey, what's up, Johnny? Building the tiniest ESP32 that's fully featured, hopefully. So long story short, I made that video about the tiny ESP32 that I made. I had some caveats. I didn't have a Wi-Fi antenna on it because I was just trying to make it tiny. Got a ton of great comments about and ideas of how to improve it, or what you could do to make it smaller. Everybody basically was saying get rid of the USB and the buttons. You don't need them. You can just short out pads or whatever if you need to put it into download mode. And while that would work, I didn't really think it was that user friendly. But there was one other person who left a comment, and I can't remember their name, but they were like, why don't you check out this type of connector? And I was like, okay, what's that? So I looked it up and actually ended up buying some just to play around with. And this is what they are. So they're these little, they come in like different sizes. These are 20 pin here, which is probably what I'm going to use. These are 10 pin. So small it's stuck to my... And long story short, this snaps into that. And this is actually the 10-pin one. It's actually assembled right now. I stuck them together, then I quickly realized, wait, I have no way to get that apart. Unless it was actually like soldered to a board. So yeah. So the idea being is that I can put this on the back of, you know, the tiny ESP32, and then I can have other breakout boards of a similar size that, you know, one could have the USB connector and buttons on it to program the board, and then when you're done with that, you can pop it off. You can make another one that's just GPIO pins that break out. So the overall footprint size wouldn't change necessarily, but it may, you know, the stack up of it would be thicker, but the actual physical size dimensionally would be just as small. I can make another breakout board that has like a USB connector on it, for instance, or another one that has you know, Stemma QT connector. Lots of possibilities. So whoever that was, I can't remember their name off the top of my head. Huge props for suggesting that. I don't know if this is going to work actually, but it's got me thinking. So that's the route we're going to explore. Yeah, it is pretty cool. I'm excited to give it a go. So let me look at this again real quick. I think this is everything we need for this particular. This is just going to be the, you know, the main board or whatever. And we'll have to make other ones that have the USB, you know, and the buttons and stuff. But we'll cross the road when we get there. So I'm going to update the schematic real quick. Okay, so we got that stuff. The easiest way to do this is actually let's just delete it. Let's start from scratch. Okay. So here's our, hopefully this is all, yeah, it's all on screen. So it's just a process that I go through. I actually think, I was thinking about this the other day. If I put this on an angle, I might be able to fit things into a smaller footprint. I still want to put GPIO, if I can, I still want to put GPIO breakout pins on just the little board. That way you don't necessarily have to, you know, snap on a connector on the bottom to use it. But another thing people, you know, a couple people suggested is like you need at least 2 GPIO pins broken out. That way you can do I2C, which is a fair point. So at the very least, I want to do that. So let's just kind of get some of the stuff close here. This is our crystal. Yeah, yeah, I have an antenna on here. Well, I'm going to add an antenna to this, correct? 245 again. Let's just see how that. Nope, let's go the other. Let's go 90. Nope. Nope. Minus 45. Oh, this isn't the crystal. That's the RGB LED. Okay. Let's, where's the crystal at? Should have this on here. That's the crystal, I think. And I'm gonna pull my schematic off the side here a little bit just so I can see what I'm looking at a little better. And I can add here. Yeah, I may use PCBWay for this, especially if they have options for that thin. I mean, when you get down to a certain point, like overall thickness, I'm not so worried about because, you know, if I'm making these little breakout boards that can snap together, you know, the thickness of the thing, you know, could be yay big or whatever. Oh, yeah. Good point, Evan. Yeah, see, just like Evan pointed out right there. I was doing it the hard way. So yeah, you know, the difference between going 0.4 and 0.6 on the thickness probably isn't going to matter except for the price you pay, you know? Okay, so and this is our voltage regulator. let's just set 45. Oh, not 445. And let's see. Where is... Did I delete the... I think I did. Yeah, I did. I need to add something real quick to this. Put that back. I got rid of the Schottky diode, which I definitely want to keep. One sec here. Sorry, guys. Update that. Okay, we need that. We need that. That feature there. Okay, so we've got that. Let's find the. Let's get all the crystal stuff. Put these next to where they need to go, basically. I still have 0402 components on here. I'm going to try and stick with that instead of going to 0201. Mainly because while my pick and place machine claims it can do 0201, I am highly skeptical of that. What ESP32, it's a C3 variant. The reason why I use a C3 is because it's physically the smallest one that they make, as far as I'm aware. So that's the reason I'm going with that one. And it has built-in onboard USB, which makes a big difference. Somebody had mentioned that there's a new S3 Pico version that basically, if you're not familiar with the Pico chips, they basically have a built-in crystal in them. So, but the package for that thing was still, I think, would have been a bit bigger. I could do, you know, through holes a little easy, nice, just because you can, you know, get stick pins on them and stuff. But, you know, there's lots of options here. Like, we don't have to do, you know, sky's the limit kind of a thing. We'll see what works. I mean, if it's getting really, really cramped, then I may consider that. Okay. So I'm going through. I always turn off all these reference designators. I don't like having them on there. There's probably like a shortcut, I'm sure, that, you know, you can just turn them all off, but too lazy to look for it, I think. Okay, so let's come over here. I don't know if doing everything on the 45 like this is really gonna save space, but it's worth a shot, I suppose. And it probably looks cooler. So, well, yeah, we're gonna have to get really cramped here. Because ideally, if I could keep, you know, the board size something like that, I mean, that would be ridiculously tiny. But we'll see. I'll have to stuff around, but I just kind of need to get all the components in their rough place where they need to be. Oh, I should have rotated that one. Okay, just get this one over here for now. Luckily, there's not too many components, so it's not going to take too long to get everything where it needs to go. Just sticking them next to each other. Let's see here. We got that one. Two. Did I change the footprint on this one? That one seems awfully small. I think I did. No, that's 042. Why does that seem so small? Dang it. To me, that feels like that's super tiny, but no, I guess it's the same size. Okay. Caps are for power filtering. Another thing, like people were asking, was like, you know, why do you need so many like of these passives on there? And they all basically serve a purpose. I got power filtering on here, and while I could probably get, you know, you could get rid of some of it, or you could even delete it all, and it might work. It probably wouldn't be very reliable. So it's just worth it to keep them on there. Again, I'm just kind of getting stuff close to where it needs to go. Okay, our antenna. We can also... Oh, that's the other thing. We need that. We need the button here. And footprint. Yeah, I know that. And is it saved as the right DF? Or did I save it as a 20 pin? What did I save that as? That's user. I saved the footprint, didn't I? Yeah, we'll see. I mean, worst case scenario, I just select everything and rotate. If it doesn't look like it's gonna fit. No, I could have swore I saved the footprints in here for this thing. Okay, let's check it again real quick. So, user, file, import footprint, DP, save. Oh, that's what it saved it as. DF40. Okay, maybe it is in there. I just didn't recognize the naming convention, I guess. Here. So it is this one? Where's the other one at? So DP, this one I want to, on the bottom of this one, I want to put DS. So that's not the one I want. What did it name the other one as? I guess I should have named those better, shouldn't I? I can't even tell which one is which. User, import, footprint. Yes, okay. Delete that, save. Maybe I didn't save it. User save. No, it does exist. Oh, HRS? That's a weird name. Save. No. All right, we'll get the right footprint here in a second. HRS. That one. Okay. Oops. Okay. Let's update it. There it is. We need to put that on the back side. I'm just going to be on the bottom. Yeah, Johnny. Let's see here. So this is for the antenna. These will go on the... I'm assuming we're just going to put these on the back side. This is for the power. Let's see. And, okay, this is antenna again. Antenna again. On the back. We're just going to throw those up top here for a second. And I don't know why I have that. I'm assuming I need that. Okay. All right. Now, the fun bit. The other thing I'm probably going to have to do, I need to figure out, let's go to 1 second. Oops. So PCB way. Need to figure out what their thinnest traces is. Figure where that's at on here. Help center. Customer service. I don't know. Let's. Yeah, I might be able to. IDF, J, A. I could. I just need to be able to leave room for this. Like this has to be on the back side. And this, you know, there has to be some thickness to it, but it's certainly possible now you mention that. Yeah, let's see. We'll see. Okay, I need to... let's try PCB way, minimum trace width. I'll lay that over for you. Okay, trace width, 6 thou. Yeah, I found it. So 6 thou. Okay, let's. I don't know what I have it set to, but I'm fairly certain it's bigger than that. Straights. Let's see here. I'm trying to think which one. Track 6 thou to millimeter is what? I guess it is this. I guess I do have it as the thinnest already. The one that I version 2 of this that I made the video on, JLC PCB made, and it's pretty freaking tiny. So like, how small were you going, Johnny? Unless they've updated. How long ago did you do that? Oh, maybe we can go even smaller. It says 0.08. Rigid. What? I don't want to flex. Okay, that's cool. Capabilities. Here we go. Yeah. Board thickness, tolerance, trace width and spacing. This is a 4-layer board, right? Yes, 4-layer board. So we can go really tiny then, 0.09. Let's go 0.10, right? Make sure I'm doing this right. .09, 0.1, okay. Yeah, that'd be way too small. Okay, so there. Let me get all these windows open. Throw this off to the side here so I can just type these in as I go. Minimum spacing, track width, clearance. Okay, that's fine. Let's see, vias, drill hole sizes, minimum via hole size and diameter. Via size is 0.15 and 2.5. Okay, I don't really use the other ones. I think that's basically it. Okay, let's see. Those are stinking tiny. Okay. So we got those. Let's start getting into trouble. So I'm gonna have, well, I can kind of start laying this out, but I do need to like actually, attach these pins to something, because, it'd be pointless if I put this connector on there and nothing's connected. So I do have to take that into consideration when I'm running these traces. Yeah, I'm just trying to think here. The other thing we need to do for the antenna is we have to kind of, it has to have some clearance room. And if I can still find, so this is the antenna. See how they have like minimum clearance areas, otherwise your signal can get all screwy. Oops. So does it say 3, 1.5 on? So 0.5 millimeter on each side. Okay, and then we have ground plane. So, and generally you don't want any ground plane underneath your antenna if we're gonna have a shot at it being even remotely decent. Okay. So going on the bottom side. This is going to get challenging very quickly. I can tell you that right now, but I think we can do it. And I'm just trying to decide whether or not I want to try and cram everything on the bottom side. So I think some stuff we're going to have to put on top. We can do a bit of both, actually. It doesn't all have to be on the top or the bottom. There's our crystal. So let's just see what kind of trouble we can get ourselves into here. Oh, I zoomed way out. Okay. So, and that's on the wrong side. This one's on this side. And this one goes here. That seem right? Yeah, something like that. We could also maybe put these on the bottom. Or maybe, I'm trying to think. I'm not 100% positive. One's a 0 ohm resistor. Let's try that. I have not done a ton of it, like custom layouts like this. I've done a handful, but I'm not like super versed in it. So this is also a bit of a learning experience for me as I go. Yeah, for now, let's just, I'm gonna try and like kind of just cram some of this, well, cram, I say, but let's just try and get it as tiny as we can here without running traces. See how big the board would be. And go from there. Yeah, kind of. I've already moved some stuff off of this that'll be on like a breakout board, like the USB connector and stuff. But let's see here. This is the antenna. Fairly certain the antenna I might have to put on the back side. Side, back. these. Not sure. Ground, ground, ground. Let me take this and put that there. There we go. Okay, so now we know where that's at. So we want to be able to keep that from itself. Hey, we're live, Mr. Decide. How you doing? You're doing it live. Or at least attempting to. Can I get a water? Like, drink water? Thanks, babe. Oh, sorry, Starfish. Very flattering name, by the way. That's my wife. I'm talking to her. She commented earlier. The pressure? What pressure? We're just having fun. If it works, it works. If it doesn't, it doesn't. Like the very first one I made of these, it's pointing at that. If you come here, you're fine. Thanks. Didn't want to be on camera. Okay. Yeah, the very first one I made, I like designed and made on stream, didn't work at all. So then I did a second version, and that one also didn't work on stream, but I figured it out off stream, and that's when I made the video, posted like, hey, this thing actually works. So yes, we will have some other elements on the other side of the board, particularly this special connector that I'm going to be using. But right now I'm just kind of seeing like how do things lay out like this. Like I have a lot of stuff on top, but I can't put stuff on the bottom. Like it might make, like I'm trying to decide, because like putting stuff on the bottom, the way things are orientated right now, you're really not going to save a lot of space. But yeah, I think, let me see here. I don't know if I can, no. All right, so AI might help. Yeah, I'll just ask ChatGTP and it'll give me some nonsense. Yeah, exactly. Yeah. Good idea. Where's my group? Grouping, group, edit. Oops. Phone's going off. So now let me rotate. I need to rotate it just 45 degrees. Properties? No. That didn't work. So I just went through the trouble of rotating all these. Let's put them all. This is KiCad, Mr. Design. It's an open source and free and very good. It's very powerful for what it is. Kind of your options are Easy EDA, or yeah, I think that's what it's called, from LCSC. It's basic, or JLCP rather. That's a free one. Then there's KiCad, which is free, which is pretty powerful. There's Altium, which is like a professional one that costs a ton of money. Definitely do not recommend going that route unless you're making a ton of money. Use the move function on a group. Okay. Learn as I go here. Let's move this stuff out of the way. Oops. don't want that in the background. Hopefully I got rid of that. Let's go group. Use the move function. Move. Okay, now we're moving them. I want to be able to rotate all the components just 45 degrees instead of doing one at a time. Move with dialog. Not seeing that. Change flip? Nope. Nope. That's not what I wanted. That's all right. We'll get through this. Grouping, ungroup. Control M, maybe? Going through all these, I'll have them all done by the time we figure this out. Group, Control M. It still just lets me move the whole group. I need to be able to like rotate all of the components 45 degrees within the group. The 33 ground, yeah, it's kind of a ground pin. The actual foot, like what comes out on the stencil, it'll be like a bunch of little tiny dots, so it doesn't cover the entire thing in like a sheet of solder paste. Because otherwise it would be quite a bit. So there's, you know, it puts solder on there, but it's not like a crazy amount. There is a move item dialog. Is it just... No, that's not it. "45 unroute, rotate counterclockwise, change flip side, properties, positioning tools." That's all right. I mean, we will get somewhere. I promise you this entire stream is not going to be me rotating components back and forth. Positioning tools. So we're going to have multiple GPIO pins, an antenna for Wi-Fi and Bluetooth. Those are kind of the main ones, really. I mentioned, I know people kind of come and go or whatever, but I mentioned earlier in the stream, somebody on my video had commented about the specific type of connector that I'll show again real quick, just in case. Did it go? Yeah. And there are these little connectors. This one's got 20 pins. This is like the female version, and that's the male version, or vice versa. And this snaps inside of this. And so I can have this on the bottom of my board, and then I can put the other one on a breakout board that can have like the USB and the buttons, so that I can snap in and plug it in when I want to program it, and then pop it out. I can also make up breakout boards that have GPIO pins on them. I have a breakout board for a battery connector, you know, so you can have a whole bunch of different functionalities depending on what you want. You can just pop in and out on that connector, which is pretty cool. So, all right, let's, almost got all these rotated back to where they were at. Let's not move these too far off from each other. Actually, I don't want to. Okay. All right, they're all straight now. So, PC. Oops, too late. Yep, got them all. Appreciate the ideas, though. me go editor. Tools. I don't know where that's on here. Oh well. Maybe we'll figure it out on the next stream. So I can rotate them like this, but... Alright, let's turn this back on. Oh, I got these two to do as well. Okay. And for now, let's just move these out of the way. I'll do this one. Make this one straight. Okay, so... Is that going to save us room? I mean, it's going to be bigger than the actual IC. Like, that's basically... There's really no good way around that with having this connector to break out the functionality. So we'll just cram what we can in here. Okay, that's there. This is there. Menu. Settings. Yeah, I don't know. It's a good question. When I right click, there's positioning tools. Positioning tools, there's move exactly, move with reference. Yeah, I don't know. I mean, there's probably got to be a way to do it, but we got them all straight. So we'll figure it out. Okay. All right, round 2 of getting this stuff crammed in together. And let's see, this one's on the outside. I don't really care if they overlap a little bit. And so it's gonna be here. Okay. We can actually probably scoot these down a bit. Something like that. Okay. That, this one, come up here. So I don't really have a, it may be the same size as what I had before. I don't have a problem with that necessarily. What's up, John? Now I'm still using 0402. The reason why I'm trying to avoid 0201 is because if I do want to manufacture these at some point, my pick and place machine claims it'll do 0201, but I'm extremely skeptical of that. It'll do 0402, so. Move exactly has rotation settings. Positioning tools, move exactly. Okay, that's just, I mean, that's doing the same thing I was doing by hitting E, but what if I select 2? Let's try that. 2. Positioning tools, move exactly, rotate 45. Hey, look at that. We figured it out. Thanks, Evan. So I could just highlight them all, go to positioning tools, move exactly, type in the rotation, and it rotates them all. We all just learned something today. How cool is that? Been editing stuff in KiCad forever, and I've always just, you know, one thing at a time. Yep. Haven't figured it out. Much appreciated. It's like, where were you, like, you know, I don't know, 3 or 4 years ago when I started really doing this? Could save me a ton of time. Okay, so this is gonna go. Let's see. So some of this, so we can save a little bit of room. Let's put these on the back. These are our passives for our, but I do have to have room for, let's see how big these traces are. Okay. It's gonna get like, laying the traces on this is what's gonna be an absolute pain in the butt. We can do it, but it's gonna be fun. You could. If I put the passives underneath the IC, I could cut off the mezzanine connector part of the PCB if it isn't needed. Not sure I follow exactly what you're trying to say. Unless you're just talking about like moving the mezzanine connector on the bottom. I'm gonna find somewhere to put this RGB LED. It has to be over here somewhere. We could have it on a piece off to the side. I'd kind of like to keep it centered, personally. But it's not an invalid idea. Let's see. Let's put. So if we put the. Yeah, I can't really put those underneath the. Get it closer up here, actually. Okay. Finding a place for this RGB LED is kind of the pain in the butt part. I mean, I'd like to have the RGB LED on there. I don't think it's like 100% required per se, but it's kind of, it kind of jets off. So finding somewhere else to put it, and I don't want it on the bottom. Put it on top of the IC, like just super glue it on top. Won't actually work. This RGB LED is 1.5 mil by 1.5 mil. I think they make, should be like a 1 mil, 1 by 1 RGB. Let's see if that spits out anything. Let's look at this real quick, just out of curiosity. That's an 0404. It's pretty tiny. How big is this exactly, though? It's in Chinese. Hopefully the sizes. Yeah, so that's 1 by 1. We could go that route, maybe. Do something like that. I wonder how much smaller that actually is. Let's That's not a bad idea. I'll just people, why'd you put that on the bottom? No, that's the top. Calling it the top, therefore I don't worry about it. 1 millimeter by 1 millimeter is. Did I do that right? Yeah. Yeah, I could maybe slim down the passive, or the not passive, the filtering caps. Just move everything to the bottom, and then we'll start over. Exactly. Problem solved. How easy was that, guys? That needs to go there. I'm gonna have to. I'll try and see if putting this on the bottom makes sense. Put the IC on the bottom. Let's see. That's the inductor. Let's see. So these are going on the bottom. Change the LDO so that pin 1 dot is better placed. Oh yeah, I can definitely move that. That's not, I'm not too concerned about that. I mean, in fact, you can just hit edit and edit footprint. And get really tiny and move it somewhere closer to the 1 or whatever. Oh, no, don't do that. Save. Now it's moved. Okay, that. I think we're gonna have to go with a smaller RGB LED. This is the one I currently have, which I think it's a 1x1 if I'm not mistaken, or 1.5 by 1.5 rather. See if that looks. I don't know. Maybe it's 2x2. This one has 2x2. 1x1, I think we can get it in there. What current is it? It puts out 700 milliamps, I think. It's a powerful little thing. I'm pretty impressed with it. Okay, let me find all my open tabs here. I'm gonna add these to my cart just so I have them. Don't forget. And the RGB LEDs, that is. And what do I do with the... Yeah, it's pretty amazing. Everything about this thing's tiny, which is pretty wild. Okay. Doesn't say which pads are which, though. Does it? I guess I pulse over here so you guys can see it. I was trying to... So if I go down here, it shows there's one... Oh, here they are. One's positive, 2 is... No, that's not it. Where does it say which pads are which? Pads. Doesn't say. Let's look on like... I'm gonna look on Mouser and see if they have something comparable. It's probably gonna cost more money, but yeah, it has a red star on it. What's this? Is this one 1x1? It's smaller than 1x1. It's like 0.8 by... But it costs $1 a piece. Or I mean a bit less if you buy. So the ones on LCSC, you can get like 200 of them for like $2.78. And on here, 200 would cost you $100, which is kind of crazy. It'd be nice to know what the frickin' footprint is on that thing, though. Well, I think they're, well, I don't want to speak, but I think they're generally fairly uniform, like, you know, the pin placements, but could be wrong. All right, we'll download this one. Worst case scenario, I'll buy a couple of these. You know. Let me need to add these to my library real quick. Uh-oh, YouTube censored you, huh? You're over there cursing. Page 5. What's that on? Page 5 of what? Google? The data sheet of... Oh. This one? Or was... Page 5. 3, 4, 5. Where are you seeing the... Yeah, I know. I see this, but like, which pins are which? Ah. You know, there's B minus, G minus, R minus, 1 plus. Oh, it's one of those. Yeah, that's not what I'm interested in. I want one that just drives itself. Let me, an even smaller one? All right, let's take a look at that. Turn the stream into looking at RGB LEDs. I think it's tiny, good lord. You weren't kidding. Let's see here. Yeah, it's kind of the same way. It's kind of like red, green, blue. I more or less want one that's like addressable. Like for instance on mine, it's like, you know, it has, the one I currently use has a ground, it has power, then it has, you know, the pin that you address, and then you can chain them together. Yeah, yeah. So you could turn on one of the, yeah, exactly. I lost my page here. 1, 2, 3, 4. This one. Trying to find where it names the pins though. I think this one's the same way actually. Yeah, it's basically like a NeoPixel, but I want one that's tiny. Whoops. 1 by 1. Let's looking to see if we can find. No, those are way too big. Don't want those. Let's see. Let's go RGB LED. Let's just search this real quick. Message retracted. Okay. Let's see here. LED. Find emitting diode. Want view angle. Red, green, blue. Yeah, that name looks familiar. Not there. Nope. Don't see it there. Oh yeah, those are like kind of weird ones. Let's go RGB LED. Which I just did, I think, but light emitting diode. Let's see here. Emitting color, red. RGB, there we go. 307 in stock. Apply. Okay, and then see if we can find a size 0404, which I think is close to what we're looking for. What about this one? Let's see here. That's the same way. Package, forward current, mounting style, luminosity, dominant wavelength, power distribution, common anode. I gotta sneeze. I'm gonna try and hold it. Oh. I haven't found a 1x1 yet. 1.5 might be small enough. One I currently use is. No, I didn't even show it there. This might be one of those things where, like, maybe on AliExpress, maybe. Yeah, I could buy a bunch of them. Those are the ones that I'm using now, actually. I am almost 100% positive those are the same ones I'm using. LCSC. Doesn't show up on here. Let's get rid of that. Nope, still didn't show up. Probably not gonna show anything. Or maybe it did. The same ones. You know, like, that's a lot of work. Like, I don't necessarily have to put RGB LED on it, but it's kind of fun, I guess. What is that? That is so tiny. They don't have any in stock, but that thing is ridiculously small. Okay, well, I can be looking up RGB LEDs all day long. Let's, for now, let's just stick that there. You know, I can come back to that. I want to see how this is going to look. I think we can put maybe put pins on each side. Okay, so let's go back to the cat here. We're going to change this. So let's do 5 and 5, I think. 5 on each side. So 4, 5. Okay, don't update. That's cool. Change symbol. 5 socket. Okay, change. Okay, that one. Hey, what's over here? You find one? Let's see. What site was that on? IDF? Not there. Oh. Actually, like, finding them was the hard part. What was that? I don't know what this... This is not what we were searching, but I was... Yeah, it looks like it's kind of the same thing. Yeah, it looks like a lot of them are like this, where... you basically have to plug several pins into it. Okay. I'll find something eventually. Maybe not tonight, but where'd my page go? There we go. Okay, so got that. Let's change this to 2. Let's select this, copy it over. And on this side, we can get rid of, we don't need the V-bus. We don't need that one there. Let's keep ground on. Having more than one ground pinned is always nice. And yeah, we don't need the rest of those. Okay, so let's see what we can break out here. 9 and 10. Break these 2 out. Might have to flip those around, but okay. And let's go. Yeah, one sec, I'll take a look at that. Like finding these and then oh, nothing there. That's the same one. Best.LED. Maybe. I know they exist. I know Sion had found one. I don't know where you found it out, but they exist. Okay, let's do this. Okay, tools, update. No, I didn't see that on any of the main sites. Unless it's on like AliExpress or something. Nope. I mean, there's best SMD, but I don't even know. I've never heard of that. Yeah, there's like a bunch of just random websites I've never even heard of. Not to say it's not real, but you know, buying stuff from random places. Okay, let's see. There, John. They're in stock. That's a no photo, but is this addressable? Yeah, it is. This is what we're looking for right here. Oops. Our pins, we got a ground, we have our input, and we ground, our voltage, and then we have an input and an output, which means you can attach these, you know, string them along. So the output of one would go into the input of the other, and yada yada yada. Okay, so that is 1 by 1. Okay. 1, 2, 3. Those are, I was gonna say, those are tiny pads there for a second. So I wonder if it's the same. Let me look here and see if this looks like it's the same. If it is, I can just shrink this particular footprint, call it a day. No, they're different. Okay, let's copy that. Let's go here. New footprint. 1 by 1. GB LED. I don't know if I can paste them in here or not. Was it? 1. Oh yeah, I think you're right. That'd be rotated. Well, the pin numbers are different. But it's basically the same thing, yeah. Okay. So, let me see if let's go here. And I don't want to save that one now. Come on. And user, which one was that? Yeah, I think it's this one. Okay, so we'll take that. Can I copy this? Copy footprint, paste footprint. That did not do what I wanted it to do. I don't know what that just did. Come on. Oh my goodness. I think we found a candidate, Mr. Decide, but I appreciate you looking. There we go. So, copy. New footprint. 1 by 1 RGB LED. Paste. Okay. And I don't need all this nonsense on here. Not that one. Trying to get rid of all fab. There we go. Nope, that's not the one. Which layer is this thing on? All this lettering. There we go. Okay, so we got that. We just need to, so the pads are 0.5 each, 0.55. Okay. 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 Let me add those to my cart so I don't forget about them. Delete those. Okay. And then we need to get these. There's what, 0.2 millimeters between them? That's pretty close. Let me come in one more. Yep, that's good enough. Something like that. It's 2. It's going to come down a little bit. Down. Whoops. Thanks for stopping in, John. Appreciate you. Okay. So that there is our, I don't care about this. I don't need a footprint, or courtyard rather. Save. Okay, so we've saved that. Let's go back to this. Change out our footprint to 1x1 RGB LED. Save. Update. Okay. That is our new footprint. It's way smaller. Okay. And let's just see what we get here as far as how big this is. Now we don't have an edge connector on this yet. Okay, so we have to make it a little, well, do something like this. Okay. So we can get this up in here. Oh, that'll definitely fit. Oh yeah. We don't have the antenna on the back yet. Let's try our little, exactly. Okay, didn't work that time. Positioning tools, move exactly. 0. What the hell? Thought we learned something here. Move exactly. 0. Rotate. All right, no, it's not wanting to work. Go back the way we used to do it. Okay. This is our antenna here. And this is on the bottom side. So that'll fit over there for sure. Oh, I see what you're saying, relative angle. Okay. Just wanna. Okay, and then I don't know where those go. Let's go something. Oh, those are also antenna stuff. Oops. We're just gonna throw all this over here for now. Let's just see how bad this looks. Never even. Oops. Yeah, it definitely doesn't need space. I'm just kind of eyeballing things right now. Needs room to breathe. So it's not terrible. I wonder if, what if we do this? What if we rotate that like that? And then try and carefully rotate these, put these here. I think we're getting somewhere now. And I mean, we could always, I could even go back down to just 4 pads, or 4 of these on each side. That would shrink it more. Although it's not the end of the world, I mean. Camera angle's like super low there. Let's go. I need to just make like some of these that don't have this crap because I don't like the. Oops. Save. You can. I plan on having a breakout on the daughter board, but I think it would still be nice to just have GPIO on the... I mean, well, it's one of those things where I was thinking like it'd be nice to just have the pins on the on the board itself too, like have options, but if we did get rid of those, we could make it quite a bit smaller. Yeah. Yeah, that's a good point. Let's just see. So I mean, if we shrunk it in like this thing's gonna be so tiny, it's not even funny. So we'd have this. I gotta move some of this stuff around a little bit. Then we have this breakout on the bottom, which I think I'd gotten the... Yeah, exactly. Let's see here. This one I'm using the DS. I need DS. That's the model. Okay, we do have a model. 1 second here. I want to see if I can load the model up so we can see what that looks like on the bottom. There needs to be enough clearance for the stuff on the bottom as well. Okay. Where is it at? $20-pin connector. Guess I already have it in there. Okay, so let's try and click that. Give me a second. Is this the right one? 20. No, that's not the right one. It's the plug. Mod file. Trying to see if I got the right one here. Downloads. Nope, that's not it. Thought that was the right one. KiCad. Thought for sure I'd have downloaded the 3D model of that. Or maybe it's in here. No, I don't think that's right. Oh, yeah, it is right. Okay, I just need to rotate it. And get it in the right position. Down a little, and then... Oh, okay, so the actual layout thing of this thing... No, that isn't right. That isn't right. That looks like the right connector, but the footprint doesn't look right now. Something's not right. It's half the fun of trying to figure this stuff out. Look this up again and find the right one. This is the one I want. Look at the part number. I'm gonna go DF40C-20DS. This one. Yeah, it's either the model's wrong or the footprint's wrong. Digi-key real quick. And CAD models. Okay, let's go. Let's go here. Yeah, DPDS. Uh-oh. Hopefully OBS is still working. It said it was. That might be right. This looks right. And we need to move it like 0.9 maybe. Oh, then down. There we go. That looks better. Okay. Save. And so this is what it will look like basically. So that should give enough room to, or however big the antenna is, but I don't think it's very thick. So that would definitely work. I want to maybe even this out a little bit here. So yeah, we can get pretty crazy small here. Something like that in that ballpark. Okay. You know, we can have the antenna off by itself. I think we can actually make this work. As crazy as it sounds. Let's okay, so we have to, there are things we're going to have to route into that connector though. So let me bring this over here because it's going to be interesting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, 1, 2, 3, 6, 7, 8. You got 10 on each side. And like I had mentioned before, pretty sure this connector can be, you can plug it in either way. So I have to take that into consideration. So for some stuff, it's got to be very accurate. So like, for instance, I need ground here and ground here. So no matter which way it's rotated, when you plug it in, they're connected to the correct pins. So I'm trying to think. Yeah, we need to send 3.3 volts out. Just use one edge. I thought about that too. I'm trying to think if we'd be giving up some pins doing that though. Because as it stands, let's kind of lay out one side and just see what that would look like. Because we need, there's some pins on here that we're absolutely going to have if this is going to work right. We got that. We need GPIO 8 has to be broken out. V bus has to be broken out. Since we don't have any buttons or anything on this thing. Our reset has to be broken out. Okay. Our boot has to be broken out. Where's that at? GPIO 9? Yeah. So that leaves us with 4 pins, I think, if I just factored everything in correctly. Which might not be... That might be plenty. Yeah, we might be able to just get away with just doing one side. And then if we put 2, 3... 2, 3, 4, 5. So boot, reset, and GPIO 8 have to be broken out to be able to put it in the download mode. Yeah, there's a lot of different ways. One of the drawbacks of the C3 version of this chip, and why it's probably not super popular, is because it doesn't have all that many GPIO pins broken out. It's only a handful that you can actually use. Oh crap! We also need our data lines. Otherwise, you're definitely not going to program it. So on a, which is fine. You're not really losing GPIO because on a daughter board, for instance, you could still use them as your normal GPIO pins. Yeah, it's just something to remember. So we would basically have 1, 2, 3, 4, 5. I guess you could use your boot button too. You'd have 6 GPIO broken out. There's reset, VBus, 3.3. I think that's everything. That's important, at least. I think that would work. And then as, I forget who mentioned it, but yeah, on like the daughter boards, then you could just plug both sides into the same pins. And it wouldn't matter which way you plugged it in. Yeah, two of these pins you can set up for I2C. It doesn't matter which ones. Not 2 and 3? I think. No, you should. You can set up your own pin definitions to be like use whatever pins you want, unless there's like a specific, reason not to. But 2 and 3 are general purpose. They're both on ADC one. ADC. They both have ADCs on them. Digital converters. Yeah. That's like if you use Arduino or whatever, like if you set up like a wire library, you can literally just you can change your pins to whatever you want them to be. Same thing for SPI pins. Yeah, I can change these around a little bit if it looks like it's going to be an absolute pain in the butt to route it. So let's okay, so and we got stuff on the bottom, right? Yes, we do. We got a bunch of stuff on the bottom. Let me see. Might be able to put some more stuff on the bottom that makes sense at least. This one's there. I mean, we could probably leave that one there. Okay. And let's rotate that around. Okay, let's just start connecting some stuff. I'm I'm gonna put a ground layer in here. There's a lot of like debate over like power planes and ground planes and stuff and boards. I've always heard that like it's a good idea to put a ground plane on your bottom layer. That way, if for whatever reason, if like the solder mask was to be scraped away or something, and something was to short out, you'd be shorting out to ground instead of power. But I mean, I don't know how often that's something you really deal with, but isn't there hardware R square C pins on specific pins? Can ESP reroute them internally? I don't know specifically. I know for a fact that you can, at least on the S3 and S2s and C3s and stuff, you can like name your pins. I haven't really done, when I really started getting into like designing ESP32s, the original ESP32 was kind of getting out of favor a little bit. So I haven't done any of those. So I don't know if it's different with those per se, but okay, all right, let's get some of this CP. I have before. You can do, I mean, I've absolutely made them with ground planes on top. I've made them with power planes on top. When you're working with such low voltages, it's probably like an absolute best practice, but in my experience, like I've never had any issues one way or the other. So just whatever is most convenient to you. Or do what you want to do. And the frequencies are so low that even like, crosstalk is pretty much negligible. It's kind of funny. I saw a talk a year or two ago where they were, it was a professor who does like PCB design and stuff, and basically, in his class they brought out an Arduino, like an original Arduino, the big ones, and he basically went over and explained like everything that was terrible about the design, and he's like, all this design stinks, but since it's so low frequency, low power, it basically doesn't matter. But he's like, it was a pretty interesting talk about all the ways they could have improved the design. And so like his class would, like at the end of the semester or whatever, they would design their own Arduino using best practice techniques and stuff. Anyways, long-winded story. Okay, so let's route some stuff here. I do think moving those GPIO 2 and 3 maybe down to the other end of the connector is a good idea, because that's where these two are at. So let's do that real fast. Doesn't really matter where these are at in this grand scheme of things. And then need to put our ground and 3.3 back on, because those are important. I might be able to move it off center, although I am a stickler for symmetry. Another, I don't know how many of you guys like design stuff, but another good practice when you're designing schematics is to put all of your power related symbols pointing up and your ground pointing down. If you have them all pointing in like random directions, sometimes it can be a bit difficult to quickly look at something and understand exactly what's going on. So if you put your ground always pointing down and your power symbols always pointing up, makes it easier to kind of take a quick glance at something and see, what's what, basically. Yep, Evan's got it right. I was pretty sure that was the case. Generally, like when you look at these footprints, like if it doesn't, specifically call out, hey, this is, your I2C, or like I said, look at the data sheet. It'll tell you explicitly if something has to be something, but Okay, so let's see now. I don't know if I can. Yeah. So I'm gonna have to go out and then in. Okay. This is where it gets fun. Is trying to rattle this stuff. Come on. What the heck? Turn it down. All right. Doesn't like to. I don't know what the heck's going on there, but why is it not letting me? Maybe that. I don't know why it's not letting me go to the center of that pen or the pad. That's super annoying. Where's reset? Reset. Let's move that down towards the end as well. So I'm gonna take reset, delete that, that there. GPIO 8. Okay. Save. Update. Okay. This is gonna get really hard really fast. I can feel it already. Is there a ground via in the pad? Maybe. That's a good question. I don't know. Let's like to be able to see where I'm going here. Oh wait, I can't. Yeah, this is gonna be quite the challenge here. I guess I'm gonna have to just do like, I don't know, there's something about these like these pads for some weird reason where it's, I don't really like that. I don't know why. Oh wait, I can barely see something, but it looks like there's a keep out. Why would there be a keep out zone there? That's odd. Edit footprint. Do they not? Probably because they. It's because they have this footprint has a keep out zone for some reason in the center of the. Okay. See these like squares here, right here? They have a keep out zone. Generally, that's. I don't know why they're doing that. That's kind of odd. Generally, you do that if you don't want like pins, you know, like a signal line or a power line running underneath something. Yeah, I don't know. Well, coming from the other side. I mean, I don't know if it actually matters. Sometimes you assume they do it for a reason, but yeah, it's kind of weird. But like, you still I mean, you still have to connect to the pad somehow. Let's go. Let me see here. This is gonna. Okay, maybe. Okay, so. So that works like that, for instance. A lot of annoying clearance stuff going on right now. Okay, it's there. Yeah, this is gonna be. Hey, what's up, MCM? Yeah, we're going even smaller, but we're adding an antenna and some other cool features. You know, the tricky part is just getting it laid out, basically. This is gonna be fun. Okay. I mean, it's not necessarily a bad thing. Yeah, it's still a 4-layer board. In years past, from what I understand, having 90-degree turns or coming into a pad on the side could cause issues when they manufactured the PCBs, like when they actually did the physical stack ups. I think that's less of an issue nowadays. But the way when I started doing this and started learning how to do this, doing this is kind of frowned upon, but you can get away with it. Okay, so we got that. Let's connect all our 3.3s. Got 3.3 there. Okay. You're still frowning. What are you frowning for? Let's actually get rid of this. Flip that around. Okay. Can I get a via in here maybe? No? Why not? Pull that down. Is that a... Oh, wait, is that like a super tiny? When you get down to this voltages, it doesn't really matter that much. It's 3.3 volts. We can thicken it up for sure. I've done that, but it would probably work fine. Just the only downside is I can't can't do a what can I do a via there? I don't know why it's. Can I do this? And 3.3. Hole diameter size must be smaller than the via size. Oh, what am I doing? I might have something messed up with the port stack up real quick. Via size, hole size. Oh, I think I have these backwards. 1.5, 2.5. And I'm trying to think. One it is here to update the. Oh, where's it at? Tools. Cleanup. Graphics repair. There should be a setting in here where you can re-update your update all your traces and stuff depending on. Wait, is it there? There we go. I think that did it. Oh yeah, VN pad. Yep, that's an option for sure. Or I guess I can do that basically. Okay, we got that. Let's see here. Connect our enable pin. Connect our VINs. Look at my schematic again real quick. Let's see. Maybe. It doesn't really like it when I'm doing that. Well, for now, I mean, that's not going to hurt anything. Let's leave it like it is. So, VBus. Which one's the VBus pin over here? Ground, VBus. Okay, so we need to connect that to that, which is going to be fun. Not ideal, but let's maybe go. We have plenty of room here. Which is shocking to say considering, you know, the size of this thing. You have plenty of room. Biggest constraint is just getting places to put a via. Let's see. Take this, move that up. No, I'm still got 0402, believe it or not. If at all possible, I want to be able to have the option to make these, like manufacture them. And it's gonna be a clearance issue with the via. Rotate the 3 decoupling caps. Yeah. Although, yeah, you could try that. Oops. We can even move them down probably. Get them out of the way. So my pick and place machine, they claim it can do 0402 or 0201. I'm extremely skeptical of that. I'm pretty sure I mean, it handles 04 or 02 okay. It's not like the best thing in the world, but it's doable. Let's take there. There we go. Okay, got that connected. And actually, I just realized actually needs to be the other way around. Come on. It's gonna be better if it's this way. Okay. here. Do that. Kind of a roundabout way of. We could do this. Do it like that. I like that a lot better. Swap the. Yeah, that's a good idea. You guys are basically designing this for me, which is I appreciated. It's been a long day for me. I'm very tired at this point. That's why it's really cool. Like I made that little video about like, you know, hey, I made this little tiny board, and comments were amazing. Like just people coming up with all sorts of great ideas. I was like, oh yeah, I could have done that, or you know, what have you. So it's pretty neat. GPIO, so we can change those. We're gonna have to change these, I think. Let's go, because I'm not using them. Okay, so NeoPixel, we're gonna get rid of these two. 3 and 4, GPIO 3 and 4 and 5 rather, sorry. So we're powering this RGB LED off of one of the GPIO pins as well. This lets us, this saves us power, and I need to swap them. I guess I could do this over here. So I put that there. Basically what this does is like when you go to deep sleep, you can turn the pin off. If I was to power this, thanks Evan, thanks for stopping in, man, appreciate it. Get some sleep. If you're going to power this off of a 3.3 volts, like directly off of the regulator, which you can do, but when you go into deep sleep, it'll still leach power. See you, MCM. Thanks for stopping by, man. Hey, good luck. Hopefully it goes well. But powering it off of a GPIO lets us turn it off in deep sleep, so we don't have to... Yeah, it's been a long one. I don't even know how long have I been going. 2.5 hours already. Jeez, time's flying by. I'm not even close to having this thing done. Or I say getting closer, but... Oh my goodness. Why is it doing that? Something like that. Okay. Okay, let's see here. Okay, then we need to VBus and VIN. So where's this going? Okay, that one's just ground, so we can actually flip that around. And I'm trying to think here. Let's move this farther down here. Flip that around. There we go. So that'll run through there. And then take... Could even just do that, I guess. Okay, those are connected. Getting all these grounds connected is going to be fun because even though I have a ground layer, there's not a whole lot of ones I can actually connect. So we are going to have to get a little creative here. Do that. Do that. Okay. All right. Connecting all the 3.3 lines is going to be So let's do, so we have a ground plane. Let's do a power plane. I think that just makes sense, honestly. Let's go for one of the inner ones. Second to the, trying to think. I'm going to do the top. I think that makes the most sense. And then no, this is a 4-layer board. I don't think I'd be able to route it on a 2-layer board. That'd be crazy. Not to say it's not possible, but actually, you know what? We are going to put this on a inner layer. So that'll just, basically what we can do here is just come out, plop a viet down, and that'll connect us to oops. Yeah, that's where the fun begins. Yeah, exactly. Fun, pain, you know, everybody's definition's a little different, I guess. I don't know why I have multiple there. That's a, or never mind. Okay. So we can pop these down, do that. That. Okay. Ground. Hope we can get that out of there. Shockingly, but fits there somehow. To make a little room though. No, we can just do that. There we go. Okay, those are connected. The rest of these 3.3s, let's come over here, put this down into our power, oops, into our power plane. See how much room we have here for that, maybe. This is going to be a very hobbled together layout. Okay, let's, come on, give me my RGB LED, please. I want the whole thing. Come on. There we go. Move it down here. Okay. So that here. Okay. Okay, then these here should be easy enough to connect. Let's pop those down to our power plane. Same for these two. Just gonna go straight down, plop it in. Okay. We are making some progress here. So we've basically gotten that side. Let's take a quick look and just see what this looks like. Okay. Should have a 3D model for this, I thought. Not that one. Crystal. D. Is that one? No, that is not it. That was way too. Excuse me. trying to remember how big this one was. It was a weird shape. No, it's one of these, I think. That's right. No, that's way too big. I had the model, or I had the model before. Looking for crystal here. Crystals. I think this is it. Rotate. Nope. Nope. Oh, it's offset. Wrong one. There we go. Boom. I think that's right. View, 3D viewer. Okay. And we have an RGB LED here, but I don't have a model for it. And the other side. And then our antenna will go here, in theory. Okay. Now the other tricky bit is D+. What are these pads? Or no. Yeah, those are D+, D-. Okay, I'm trying to think how to get... Trying to figure out how I'm going to get these here. I don't know why that one's so big. Why is that so big? So I need to swap those two around at least on the connector here. So let's go D minus D plus. Save tools, update. Okay. And let's see what... I don't know why all of a sudden... Why are those so much bigger? There must be some constraint here for... Constraints? Oh. Oh, man. That's weird. It's got to be some corner radius, corner size, route position, clearance and overrides. I don't know why it's making the trace so wide when it comes off of that. I don't know. Huh. It's probably some setting somewhere that like a signal line for positive has to be a certain width, maybe? That I don't know. It won't even let me come off of the oops. Hey, what's going on, Ed? Yeah, it's been a long day. Trying to... I don't know if it'll let me... Nope. Oh, my... Actually, I wonder what it... Maybe I should have those backwards. That is really strange. Track width 0.1. Oh, right. It's because it has the keep out zone on the side. Forgot about that. Footprint. Let it think about it. Yeah, I don't know why it's set to that. It's weird. Oops. Edit. Edit footprint. Trying to... We're gonna break all the rules. Save. I do what I want. As far as running traces. Actually, I wonder if it'll just let me do that. No. Okay, there we go. Well, if it's doing that for a reason, I don't want to upset it. I'm actually going to flip these two back the way I had them. T minus save tools update. Close. Something like that. And then come out here. It's gonna let me move that up a little bit. Okay. Those are connected. Not very prettily, but I don't know if that's a word, prettily. So this one was... Oh, no, I just want to rotate it. Okay, look at my schematic again here. So that one's the first one, second one. So something like this. Actually, try and get this. Ah, maybe that's the case. Well, I still got it connected, so. I think about there, so I'm trying to just get it somewhat even. I don't mind having, I mean, if it's thicker, it's fine, as long as I can still route stuff. That's gonna be a problem now. Oh, okay, let's rotate this again. Move this one to the side. These two over here. Something like that. That one. Something like that. Okay. Okay, like that. Let's go through. All right, I'll do those two. Getting that back over here is not going to be easy. Oh man. Put a little. Nope. Change this to X N. Okay. Let's get rid of. Huh. That's odd. Getting that through. Something like that. Okay. Okay, we got those. Put some. Oh, no, don't like that. Actually, that's probably a good point. I don't want to put these where they're not supposed to be. And just put that there. Okay. I don't know why that's not connected. Let's see. Let's do that. Okay. All right. We're getting there. Slowly but surely. I'm actually going to okay. All right. So we got all that. I think the last things to connect are the antenna itself. Up around the crystals, ground pin, and to the right along to the cap, all on the top layer. Yeah? I think they're all on the top layer. Oh, are you talking about, yeah, these grounds not connected? Yeah, we can manually just do that. And then, is that a ground underneath it? Yeah, it's a ground underneath it. So we can do that, and we'll just connect them like so. Okay. So that one's that one. That's coming, actually. Different, what do you mean different layer? I think those will work. I need to get these sorted out though. So that's gonna go there. I really do need to flip those around. I need to get rid of that via then. Do this. Something like that. Like so. Okay. All right, come off. You have a ground layer, why not just put the ground pads to that, leave on the top layer, no via to the orange. It's only because I can't get around this, my signal line. There's not enough clearance around this stuff to get this through there. That's the only reason I went that route. Like that. That's the only reason. Let's see here. Yeah, okay. I think that's right. That is off by itself here. It's generally not a good idea to run stuff underneath the crystal, as I understand it. Ugh. Or I should say directly underneath it. Whoops. Don't want to do that. My inductor here, but that does not need to be up there. It needs to be somewhere else, I think. So we will which pin is that one? Pin 2. Where's pin 2 at? So it's that one up here. Okay, so let's do this. Top layer, like so. Let's do this. I'm trying to think here. Yeah, let's go up here. Okay, got that. Okay. Okay, with those connected. It's gonna go through what's there. Part of me wonders if that's even right. I'm looking at this antenna thing real quick. Google Drive. PC, ESP32, nope. PCB files. Yeah, it looks right, okay. And that goes here, I think. Then oh, the other thing we need to, almost forgot. So this is on the bottom. This is the ground layer, right? No. Where's the ground layer? Where's the other one? This one. I need to edit this. In fact, I'm just going to do it again. I feel you, Mr. Decide. I'm getting there. I'm getting close to that myself. Thank you for stopping in, man. I appreciate it, though. Have a good night. Get some rest. So let's... Okay, so we don't want a ground plane underneath that, and I don't think we want the power plane underneath that either. So let's, oops, delete that real quick. Just draw up again real fast. That was 3.3. Okay, so close. Okay, so we don't have anything underneath our antenna, which is important. Nope. This layout's pretty ugly, but I don't know why. Those are not connected. Just kind of odd. Maybe green or on this layer. Come up here. Let's run our DRC and see how bad this is. Yeah, I don't care about those. VIA is not connected. It is not connected or connected on only one layer. Oh, yeah, maybe we should do. Nope, not that one. Where's the other one at? Let's do this. See if that does a better job of it. DRC. Now we have unconnected ends, which is pretty common. Design rule checker. Drill out of range, net class default minimum 3, yada yada yada. Okay, let's figure out where we. So I don't care about that because that's technically connected. That's technically connected because basically it's going through this inductor and then connecting, so that's fine. And that one's not for some reason. Oh, it's that right there. Yeah, so those are all basically connected. So I think we have everything. I think we have everything connected technically. I'm probably gonna have to clean some of this up later, but or I absolutely will have to. But yeah, it's looking pretty close. Kind of cool. So, out of curiosity, let's I think that's, yeah. I don't want to print on a thermal. I'm going to print it off real quick. And then we can compare it to the version 2. Let's give it a second here to print off. And okay, let me go to this one. Yeah, this one will work. Grab my moment of truth. How big is this compared to the one I made the other day? Oh, sorry. I'm going to zoom in a little bit. So that's the one we just designed. And that is the version 2. So it is considerably smaller, it looks like. In fact, maybe we go to, so which one is it? 9. Let's see if I can't put this on here so it's a little closer to. So that's roughly the size of it. So that is way smaller, which is cool. And then we'll have breakouts and stuff. I'll have to make some breakout boards, but it's pretty cool. The antenna position is on the bottom side, just right here. It's off in the corner. It's basically as far away as I can get it from anything, right here. And there's no ground planes or anything underneath it. That's what this cutout is. I'll have to open up the data sheet later and actually look at it proper and make sure like there's actually the other side. Yeah, it's generally bare. It's like I'm pretty sure it does not connect to ground. Here, like if you see here, this example, it connects, and then the other end is radiating out more or less. I will double check that before I send this thing off to be made, but yeah, it's basically unconnected, is my understanding. No, what do you mean the other layer? It's not connected? No, I mean... as far as you mean like the components on the other side? No, I don't think so. Maybe, maybe not. I'll have to play around with it. Like I said, I'll have to look at my look at the data sheet later. I could potentially, let me look at this real quick. I mean, I could potentially like cram everything to one side here. There's a bunch of, doesn't like all these connections that leave that one there. Do that. Do something like this. Put this over here. Maybe if it'll let me. I'll have to look at the data sheet. Yeah. It's not that it's necessarily important. It's that I need to try and set it up so that it's 50 ohm impedance. That's the important bit. I have a VNA that I'll use to try and network match it. That's what some of these components are for. Not this, what I'm moving right this second. But what's going on, Kyle? I am just trying to cram some more of this in here. I had everything laid out, and then IDFJ, GA. I pointed out I probably should try and get this as little as I can underneath there at least. This thing being as small as it is, and as small as this antenna is, like it's not going to be your signal strength is going to suck regardless. So then take this down here a little bit. So, okay. Right, this again real quick. Oh, there's 5 unconnected ends. Oh, that. Let's tools, cleanup tracks, date. Built that. Okay, so that's not connected below it. Okay, so that's connected. That's not connected for some reason. Should be. I don't know why it's like that. Thank you.
Mm-hmm.
Okay. Is the name of the net name of the ground plane correct? Yeah? Should be. It was connected a minute ago until you made me move everything over here. I blame you. No, I'm joking. It's probably just some weird connections, something or another. When in doubt, let's put on a few more. Oh, no, I don't want those. Wrong ones. Let's try this. Let's just... Maybe not exactly good practice, but... Now it's connected. Okay. Yeah, those are fine. That's fine. Yeah, that's fine. That's fine. Okay. View. 3D viewer. Boom. There she is. For what it's worth. I'll go through and clean a lot of this up. I mean, this has been a pretty rough layout session, but it all fits technically, which is pretty cool. So yeah, I'm excited to see how this works out. Those are pretty kind of close together. If I can move this, yeah, move it over a little bit. Something like that. And that goes to nowhere. Now it's not connected. Okay. All right. I think I'm going to call it there for now. I've been going for 3 hours. We had some good ideas, some very helpful conversation in the chat, and I really appreciate that. So, yeah, we'll clean it up. I don't know if I'll stream more of, probably not cleaning this up, but I don't know if I'll stream any of the making of the little breakout boards that go with it. But, yeah, we'll do some cleaning up on this. Try and get it ordered. Hopefully, neither of the PCB houses, either JLC or PCBWay, complain about the size of these traces and vias. They might, but who knows. And yeah, we'll go from there. So thank you for watching, guys. I appreciate it. And until the next stream or next video or whatever, I will see you all next time. So, and if you've made it this far and you've not subscribed already, please consider subscribing. I'd be shocked at this point. If you made it 3 hours in, you're like, I'm good. So, all right. I'll see you guys later.